steel stud gauges. Okay, there's obviously different stud for certain things, guys. Obviously, right? Now, whether you're new to the trade or an experienced guy, okay, please let me know if you guys have any suggestions or input to what I'm saying. Okay, I'm just trying to teach you guys what I know. I know quite a bit, and I realize that other guys might have different methods of doing things and stuff, which is fine. It's cool. I dig it. Right? So we're here to share ideas, right? Not like criticize each other, and you know what I mean. Let's just share ideas productively, and be better together. You know what I'm saying? But, whew, okay. So right off the bat, we know there's light gauge, heavy gauge. Okay, so for exterior building, we're always using heavy gauge. Now we're gonna probably use 16, 18 gauge. Normally on for exterior building, okay? 6-inch, 8-inch, 10-inch, okay? Those are pretty standard exterior sizes. And there's two different types of studs as well for the heavy gauge, right? You have your normal heavy gauge studs, and then you got your structural wind-loaded studs, right? Like for load-bearing walls or for wind loads, they can tell them because they have the oval cutouts, right? They're fully oval, and the other ones have the flat bottom, and then just like the half moon or whatever, I'll show you examples as we go along here. Interior almost always is 25 gauge and 20 gauge. Okay, so 20 gauge would be the heavy gauge interior. It's a really good product. Okay, I really enjoy framing with 20 gauge. It's so much better. Like it's the 25 gauge product isn't like the greatest product in my opinion for walls, right? For doing ceiling work, it's great. Like bulkheads, ceilings, funky detail stuff. Light gauge is great. But I like to use 20 gauge for my walls. Okay, it's a better product for walls, like especially for free floating walls. Either way, it doesn't really matter. Okay, it's just like double the price almost. Okay, like every gauge you're almost doubling your price. Okay, for thickness of steel. Okay, we'll talk a bit about that. But here's some standard sizes that An inch and 5/8 is the smallest you're going to get for a stud size. Now, if you want to go, if you need something smaller, that's where we come into the furring bar, which is 7/8. Okay, and you don't get any smaller than that because you're basically at that point just going to be laminating drywall right to things. For studs, though, you're starting at an inch and 5/8. All right, and that's a really tiny stud. So those are depending on what kind of details you're working on. Like it just all depends on the details. For walls, and you're not so much. You don't really use the inch and 5/8 for walls. Like maybe for like a wall in front of a concrete wall or another type of wall, or like like a furring wall or something. But columns, people use them for columns to keep the columns nice and tight. But I like to go even tighter on columns, and I just use angle and furring bar. Okay, and just double layer the drywall or single layer drywall, whatever. Okay, I just get it tight as possible, nice and square. And you want to keep all your columns the same size. You don't want to have them all different sizes. Okay, so you got to check for all that stuff ahead of time before you start framing. 2.5. I've used a bit of it. More in bulkheads is again like same with the inch and 5/8 bulkheads. Same thing with the 2.5. Otherwise, unless it's a special detail of some sort. 3.5, I've honestly never, ever seen 3.5, to be honest with you. 3 and 5/8 standard, right? That's your standard 2x4 in steel stud. Okay, it's 3 and 5/8. In wood construction, they're going to call it a 2x4. In steel stud, we're going to call it 3 and 5/8. 4-inch, and that's another size I've never ever used is 4-inch. 5.5, another one I've never seen or used before. 6-inch, now that's where we go. Okay, so mainly 3 and 5/8 and 6-inch are standard interior sizes. Okay, so for any wall that has plumbing inside of it, you're going to use 6-inch. Any room that you need sound rated, even you should probably go 6-inch, and so you can go with like R20, like a bigger bat for sound rating. There's other ways you can soundproof. You can go 3 5/8 and then double layer 5/8 using green glue. There's also res bar, which is another 1/2 inch as well. Resilient channel we call it, or res bar for short. That can go in, and you can, yeah, it's all sound related stuff. Okay. But yeah, I always go 6-inch. My studio, like I said, it's got a 2x4 wood wall, and then on an inch airspace, and then 16 gauge 6-inch steel stud all the way around, R20 poly, and 2 layers of 5/8 type X with the green sound glue in between, okay, for sound, and that's all the way around. It's beautiful for sound. But plumbing walls definitely have to be done in 6-inch. Then we get to more like the exterior steel stud, which would be 8-inch, 10-inch, okay? 12-inch and 14-inch, also never ever used 12-inch or 14-inch before, okay? Never have. So I'm thinking maybe if you got like super long, like super high walls, you can't have any breaks in or something where you're rolling studs on site, you could go bigger, and so maybe, I don't know. I'm not so sure. But yeah, so 8-inch and 10-inch are pretty normal for exterior. 6-inch sometimes too, okay? We do it in 6-inch as well, right? But 8-inch is pretty much a standard for exterior walls, okay? And that's, again, when we're getting into the heavier gauge. So you're going to start at like 18 gauge with that. 18 gauge and 16 gauge for that. Okay, you don't again, you're not gonna use the smaller heavy gauge studs outside unless you're framing things like pilasters, which are little details, and then like for brick and all that, and or like soffit ceiling stuff. You know what I mean? Like that's, or even parapets. The parapets are gonna pretty much match. Not gonna pretty much. Are gonna be the same thickness as the wall below. Okay, you're matching it at the top, the parapet. Okay. Yeah. So that's it. That's the standard anywhere. It doesn't matter where you are in America. That's the standard. So the flange sizes. Let me show it just so you know what I'm talking about. I forgot what screen I'm on. So yeah, this is the flange here, and you can get this in different thicknesses. I gotta remember which screen I'm on. But yeah, this is the 6-inch, 16 gauge. 6-inch structural. These are structural studs I used all the way around my studio, and trust me, guys, they were left over from a job. I had enough to do my garage, so like my studio. So I didn't buy it, but it was like probably a few $1,000s worth of steel that I got to use in here just because it was left over. So all right, so 1.25 inch is a standard size, a standard flange. The 1 3/8, 1 5/8 is not so much, not so like familiar with that. This is actually, do I have my tape? Let me check this. This is an 1 5/8 flange, okay? So this is a pretty, and then the 1.25 for the light gauge studs, okay? They have a 3/4 either side for the drywall, and this is why I have an issue with the Easy Light drywall. If you use Easy Light drywall, the sheets are smaller, right? So when you're doing your drywall, your bevels are running off, once you get a certain length out. It's just so frustrating, right? And you also have to be aware, it doesn't matter what type of drywall, standard drywall, Easy Light drywall, when you're, 8-foot sheets, 12-foot sheets, 10-foot sheets, they're all slightly different in thickness, right? So you're doing 12-foot stand-ups and then you're doing 8-foot tops. The bevels aren't going to line up over time, right? So that's why sometimes we it's actually nice when you have tops, when you 12-foot stand-ups and then 2-foot tops, and then you can cut a 12, like 2-foot tops out of a 12, and it's always the same. That's always nice when you can order just one size of board too. But anyways, the flanges is an indication of strength as well. So you can have a heavy gauge with a fat flange. It's going to give you more strength, okay? But yeah, so 2-inch is is a structural size. That's big. Okay, when you're getting the 2, the 2.5, I have seen 3-inch thick as well. Big fat studs, you know, like those are wicked size, right? But for installing them, heavy gauge is a little tough. You don't get 2-inch flanges. I don't even know if you get 1 5/8. You might, but the standard light gauge flange would be 1.25 inches, I believe, right? So you're only gonna get that 1.25 inches on light gauge. You're gonna get bigger sizes only when you start getting into 20 gauge and higher. Okay, not on the light gauge stuff. Not that I'm aware of, but correct me if I'm wrong. But yeah, so let's see what this guy says. So Canadian light gauge steel stud framing sizes. So this would be American and like, you know, USA, Canada, all the same. Okay, it's the same stuff. Light gauge steel stud framing used for interior wall partitions in America comes in various shapes, thicknesses, sizes, and finishes. Each of these components has a specific function in the wall assembly. Selecting the correct size and thickness will depend primarily on the spacing of the framing members and the height of the wall. Steel studs framing manufactured lengths in America ranging from 8 foot to 24 foot, and tracks which come in 10-foot lengths. Yeah, all tracks are 10-foot lengths. Furring bar is, you can get furring bar in like I think 10 and 12, I think. What else can you get? So no, like carrying channel, always 12 foot. Angle, I think, is always 10 foot too, I want to say. I think angle is always 10 foot as well. And tracks 10 foot. Only some things you can get bigger. Res bar, again, 10 foot. That's all. I think that might 10, maybe 12, maybe. I don't know. We can check if you want, but. So 1 to 3 millimeters for structural. That's your thickness and gauge, obviously. 1 to 2 mil, so minimum 1 millimeter, right? So it's insane, because if you think about the density of a 2x4 wood compared to its counterpart in steel, like that's amazing that the insulation can really basically butt up to each other almost, you know. And it's pretty cool. Boom. So their higher strength allows greater spacing between members when compared to wood frame construction. About 24-inch, 600 millimeters for LGS versus 16-inch or 20-inch, 400 or 500 for wood. So yeah, we still use 16-inch centers most of the time. In America, we don't go 2 foot on center. We build things tough here because we have winters, we have 4 seasons, we got crazy, like, you know, like we build things strong. 2 foot centers is something they do in Europe a lot. To me, it's really weird because it doesn't support the boards very well, in my opinion. Okay. If you were to go 2 foot on center and then insulate it with like a rigid polystyrene or something like that, and then put furring bar or something horizontally, then put board on, I could see that, you know. But it's just a little weird to me. The 2 foot centers. Sometimes we do it, but it's so rare, guys. It's actually really rare. When I don't do 2 foot centers very often. So, yeah. So that's cool. That's that one page. I'm surprised it didn't really get into gauge, did it? Like that's a short page, but I got a few more pages open. There we go. So steel studs are much more efficient to use than wood studs. Instead of making customized wooden studs on site, it is always better to use different gauges of steel studs, which are easy to install and maintain. So yeah, that's another point I never really thought of. So when we're wood framing, sometimes we're putting like multiple studs together. Okay, with steel, yeah, you can just use a heavier gauge, right? And that's so much more efficient, right? If you know what I'm understanding. In wood, like we'll put 3 studs together, or however many studs together, you know, for whatever, like around windows and stuff. There's also the, like, you know, those headers that we build, and with the 2x10 or whatever, is it the 12 or something? I don't know. Anyways, you know if you've done wood, you know what I'm talking about. But with steel, we can build box beams and use heavier gauge stuff, so we don't really need to do a lot of that stuff. Okay. Steel studs are used in places where there is a high chance of floods. So light gauge steel stud framing is used across many different construction sectors, along with the benefits of fast track construction and ease of handling light gauge steel studs. Look at this guy. So light gauge steel stud framing also offers a highly sustainable method of construction. Production in an energy efficient. It optimizes lighter structures, meaning that the footings can be less extensive. So yeah, it's lighter, stronger, and straighter, resulting in a dynamic designing and labor cost savings. Yeah, you'll always have corners, straight walls and corners with steel stud, which is fantastic, right? All right, here we go. Now we're getting into some more technical. So actually, if you look here, this is a structural stud, and here's actually, I want to show you, this is a great picture. This is a suspended system, okay? And these clips, oh God, guys, I love that you can buy them now with the slots, but before we used to have to make these. What we would do is we'd cut a piece of track in half, and then we would cut slots for the slip track, basically. So these clips, you shoot to the I-beam at the top, just below the roof there, and you want, this is where the rotating laser comes in, and you set an offset down on one corner of the building. Okay, you set an offset, you get a rotator laser going, and when you're installing your clips, okay, you want them to be like no more than a 1/4 inch behind that plane, okay, because you want the clips out as far as you can for when you're attaching these studs. So a lot of guys will also put them bang on. That way, when you're putting your stud in, all you gotta do is clamp it, and it's already kind of lasered in, right? This is where the reader comes in, you know, ding, 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 and you clamp it or shoot it, whatever, okay? 16 inches apart, so you got to lay it out on the I-beam where your studs are going to be. These literally, you're going to have a bottom track. You might have 2 rows of clips depending on how high the building is. But this system is on the outside of the structural steel. The slots in those clips allow it for deflection, okay, which is really, really neat. And then the parapet, it's just, you don't have to frame the parapets after, it's just straight up, which is nice. I do like this system. Parapets, you know, is a break between that I-beam, and you end up having to like insulate and tape and all, you know, like all these I-beams before you board them and stuff, right? So yeah, I really like this system. It would just be a normal bottom track, but yeah, those ovals are usually the indicating a structural stud. So you can see the flange is thicker, and the part that even comes in off the flange here. Okay, so this whole flange is beefier than a light gauge stud. Okay, let's see here. What do we got here? Yeah, these punches. Okay. There's 2 types of patterns, it looks like. So the east and central punch pattern. So east and central punch pattern, the knockouts start 1 foot and then 2 foot. They're always going to be 2 foot off the ground. Okay, 2 foot centers, because all your insulation, everything like that, is based around 2 foot intervals. Okay, your bats will be 40 inches wide by either 16 inches or 24 inches. And so these knockouts, right, you want them always to line up. That's why we're always measuring from the bottom up and cutting the tops of our studs off, because we want all the knockouts to line up to put our carrying channel in. All of this exterior stuff needs to have carrying channel and clips even, right? But there you go. That's a great drawing right there. So you see right there, here's your lip. There it is, the lip. So these got a bigger lip. And this is your flange, and then of course your Y to Y is your web width, the web, yeah, right, and their X is your knockout. Okay, that's your knockout. 2.5 inch, wow, 2.5. Oh yeah, that's actually, I have seen the 3.5 little ones. They're like 3.5 with the thick flanges and stuff. Yeah, I have seen those. 4 inch, again, I've never seen 4 inch or 5.5 inch, but that's what that is. 600, so you'll see the codes here, okay? 600S, 8 inch, the 800S, okay? 10 inch, Obviously 1000S, 1200S for the 12-inch. Flange sizes, we've gone over that. Thickness, so 33 mils is 20 gauge, 43 mils, 18 gauge, 54 mils, 16 gauge, 68 mils, 14 gauge, and 97 mils, 12 gauge, baby, 12 gauge. Yeah, 12 gauge is heavy duty stuff. I don't think I've ever actually used it myself. I've used like 14 or 15 gauge. I just wanted to see. So 14 gauge, yeah. So I've done 14 gauge actually. Yeah, that's a heavy duty stuff actually. What do we got here? So 54 mil, 16 gauge. We got that. Oh no, 54 mil, 16 gauge, 68 14 gauge, 97 12. Those products are produced with 50 KSI steel unless otherwise noted. Standard coating, CP60, G60. It's like galvanized, right? Galvanized, basically, right? Additional member depths of 7 1/4, 9 1/4, 11 1/2, 13 1/2, and 14 inch are also available. That's interesting. I've never seen those before. All studs are color coded and easy for identification. Yeah, I have the color codes we're gonna go over too. But yeah, let's see here. Let's check this out. Clark, look at that. Clark Dietrich S137. That's the 1 3/8 flange and a 3/8 return. So that's a 3/8. That's a big lip, yeah. And are used to support the exterior skin or cladding material, metal, stone, tile, glass, etc., and the wind loads to which they are subjected. Right. That's awesome. The 162 members have a 1 5/8 flange and a 1/2 inch return, and are considered the industry standard. Yeah, that's for the exterior. Yeah. S162 members are preferred for most curtain wall applications. They also provide the vertical strength necessary for demanding load-bearing structural applications and sufficient strength for many joist applications. So yeah, that's what that is right here. This guy, right on. That's pretty awesome. And then the S200, the 2-inch flange and a 5/8 return that provides a larger bearing surface for attaching subflooring or sheathing materials. This framing member is also used in axial load-bearing wall assemblies. So the 2.5 inch, the members that the S250 or whatever, 2.5 inch wide flange and a 5/8 return are used in floor joist assemblies and heavy loading conditions. So, yeah, man, that's a good thing to point out there. This is the S300. They have the 3-inch flange and a 5/8 return and are used in very heavy load bearing and long spanning conditions. That's what I'm saying, like long spans, height or length. That's where you get into the thicker flanges, right? So it's pretty cool. Let's see here. Yeah, there we go. So here's our color coding. Bailey, this is great. Yeah, Bailey. So you can also see the clip system. Let's see if I can zoom in on this guy. Boom, boom, boom. There we go. Right on. So yeah, you can see the clip system here as well. Look at these guys. Every single stud is clipped, right? Well, yeah, look at this. Wow, that's cool, man. All right, so 20 gauge is white. So they're going to spray paint the bottoms of the stud white, okay? Right? So you got 8. Oh, this is an 18 gauger. This one, yeah, this has got the yellow, okay? This one here has got the yellow for 18 gauge. Okay, so 20 gauge is white. 18 gauge, yellow. 16 gauge, green. 14 gauge is orange. And 12 gauge is red. If you're not learning and you're trying to go and get material for a journeyman or something, you should know the colors because, you know, especially in a big jobs. That's another thing. They're more relevant on a big job, right? Because of all the different materials, and you'll have multiple laydown areas and stuff like that, right? So Yeah, when you got lots of crews going and da 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 da. Yeah, it's good to know the color codes, especially for the new guys. The laborers or the apprentices need to know so they get the right stuff. Let's see here. The cold form. Steel framing manufacturers use a universal designator system for their products. The designator is a 4-part code which identifies depth. Okay, that's good. So structural product identification. The cold form steel framing manufacturers use a universal designator system for their products. The designator is a 4-part code which identifies depth, flange, width, member type, and material thickness. So look at that there. Member depth in 1/1000th or 1/100th of an inches. So thus 600 means 600 6-inch. Yeah, right. So 600, like we were saying before, 800 would be 8-inch. And so on, right? Flange width is also in 1/100th, so 162 is like an inch and 5/8, right? 1.62 or inch and 5/8, and the 54 is the 054, okay, which is your gauge, right? So 054, if we look back here, okay, 054 is 16 gauge, right? So 054, 16 gauge. And yeah, look at that. So C stud. There's your different stuff. Okay, perfect. Yeah, so your C stud here, your slash joist. Okay, S sections, T section, your track. It's simple, right? There's different tracks. You got your slotted track for your like walls that go to underside of structure, and you need for deflection. Okay. U sections here. Like channel, yeah, U-bar, channel, duh. Oh god, F section. Oh, that's cool. So furring channels. That's the furring bar, the 7/8 thick stuff. The furring bar, okay, or hat track. Some people call it too, which is weird. I guess because it looks like a hat maybe. But yeah, that's interesting. F section, U section, T section, S section. But yeah, there you go. The galvanized sheet gauge. I'm just going to talk about the coating just because they're all pretty much galvanized. I don't know too much. They might be different ratings for that, but I wish I could get rid of this side as well. But let's just check this out. So the galvanized sheet gauge is an older system used primarily by the trades consuming non-structural galvanized steel and is a measure of the zinc-coated sheet thickness. It was developed in the early days of galvanizing before sophisticated wipers were available, and consequently zinc thicknesses were thicker than today. The GSG system, I'm sorry guys, was used on some of the older gauge charts published years ago that unfortunately still seem to get used even today. So, yeah, like we basically call them. Look at that gauge number, design thickness, minimum base steel thickness, right? 95% of the design thickness, and then your nominal base steel thickness with your finish. So that's it. That's cool. So sheet steel products are normally coated with a metallic coating, i.e. zinc or 55% aluminum zinc alloy, and also may be painted. The thickness of typical hot-dipped metallic coatings are given in Table 2. The metallic coating thicknesses must be added to the base sheet thickness when determining the delivered sheet thickness. Metallic coatings are also subject to manufacturing tolerances the same as the base steel. Therefore, the actual thickness of the metallic coating may be greater than the values listed in Table 2. This factor needs to be considered when attempting to, whatever. So there's just different machines or manufacturing processes might change it a little bit, but this is your baseline here. Okay, so we don't really worry too much about that. When we order studs, it's all in the specifications. Sure, like if you actually read a spec book, they'll specify the coding and stuff like that. But it's like pretty much standard, right? Like you don't call up your supplier and say, hey, I need some gout like this coded in what ZG whatever, like it is just what it is, right? All you need to know is what's specified. So your gauge and your lengths, of course, quantities, but you want to know the gauges, your heights, your thicknesses, so your web thickness. Okay, so that's 3 5/8 or 6-inch. If you need any specialty stuff, okay, then you can ask for different flange sizes for strength. Okay, if you need structural studs or whatever like that, you can go with the thicker flanges, and so on. Okay, so you need to know, you got to be aware of flange size, web size, and gauge. Okay, that's the main things. Heights, of course, like that's just a matter of you're taking it off, right? But you don't need to know about the coatings. Okay, all the stud you buy is going to be coated already, galvanized. So yeah, so that's about that for that subject. Anyways, you know what I'm saying? But yeah, so I just thought I'd go over all that stuff with you guys. I hope that helps you understand the gauges and stuff like that. I don't know if there's any questions you guys have for me. If you guys want to talk about anything, let me know.